So we are going to do the January 2015 Algebra 1 Regents, questions 1 through 22. And question number 1 says that the owner of a small computer repair business has one employee. And this employee is paid an hourly rate of $22. The owner estimates his weekly profit using the function p of x equals 8,600 minus 22 times x. In this function, x represents the number of what? Okay, so we know that, so we see x is paired with 22 in the function. And we know $22 is the hourly rate of the employee, right? So we know this is going to be $22 per hour. So this x is going to be the per hour. So x is the hours worked per week. Question number 2. Peyton is a sprinter who can run the 40-yard dash in 4.5 seconds. He converts his speed into miles per hour as shown below. Which ratio is incorrectly written to convert his speed? So each fraction that we write it so that we can cross or cancel out the units from before. So this yard that's up here from 40 yards, we can cancel that out with this yard down here. And we're going to want to continue making those crossings until we figure out which one is incorrect. So let me go down to seconds here. Do we see a seconds in the top? Yep, we do. So that's correct. Let's go into the 3 feet here. Do we see a feet in the denominator? We don't. We see one here. But let's continue. All right, let's go to this minute down here. Do we have a minute in the numerator now? We do up here. Right, and we know that we wanted miles per hour. But as we see here, miles, it's on the wrong side because we want miles per hour like that at the top. Hour is in the right spot. So this is okay, but miles is the one that's on the wrong side. And it's also not matched up with feet properly. So the incorrect ratio is this one, and that is answer choice 2. Which equation has the same solutions as this quadratic function? 2x squared plus x minus 3 equals 0. Okay, there's a couple of ways to do this. One way is to factor this out, right? But this isn't an easily factored quadratic. But I will show you how to for anybody that wants to use the factoring method. Okay, so in this case, you have to, since a is not 1, first thing you need to do is multiply these two. 2 times negative 3 equals negative 6. So we want to find the factors of negative 6. Let's start there. Let's just find the factors. So 1 times negative 6, negative 1 times positive 6, 2 times negative 3, negative 2 times positive 3. We want to find which factors add to the coefficient here, which is an imaginary 1. So what adds to 1? Well, 1 plus negative 6 is negative 5. Negative 1 plus 6 is positive 5. 2 plus negative 3 is negative 1. And negative 2 plus 3 is positive 1. So that's our winner here. So we get 2x squared. There's a minus 3 on this side, right? And I want to keep the 2 paired with the 2 and the 3 paired with the 3. It'll make it easier, and you'll see why in just a second. So we got minus 2x plus 3x. You can see these are the same equation, right? As if we just combine like terms, it would be the exact same. Okay, and now we want to kind of split this in half and factor each side. So I notice my common factor here is 2x, which leaves behind x minus 1. Okay, let's repeat that. Our common factor here is a positive 3. You should keep the positive, right? And we get x minus 1. And something super important here, these two need to be the exact same. If it's a little different, like a sign is off, instead of factoring out a positive, factor out a negative. That sometimes fixes it. Okay, and now I'm going to bring the 2x and the 3 into one binomial, and the x minus 1 is going to be the other. We get 2x plus 3 and x minus 1, our answer is 4. And if you want an incredibly quicker way to do this, let's use our graphing calculator. Go to y equals and do 2x squared plus x minus 3. And now you're going to put each answer choice in here. So I'm going to start with the correct one since I already solved it. 2x minus 3. Sorry, it's plus 3. And x minus 1. Second graph. Our tables are identical, so that is the correct answer. Whichever way you prefer, guys. Question 4. Crystal was given $3,000 when she turned 2 years old. Her parents invested it at 2% interest rate, compounded annually. Annually means every year. No deposits or withdrawals were made, so the money didn't change. Which expression can be used to determine how much money Crystal had in the account when she turned 18? Okay, so we need our formula here. And our formula, once you start seeing investing and interest rates and questions that appear like this, usually about something growing or decreasing at a percent rate, you're going to use the formula P equals I 1 plus or minus R to the T. And I'm going to clarify these letters for us. So I is going to be the initial value. And in this case, that's our 3,000. So whichever one we choose, we want 3,000 outside the parentheses. And every answer choice actually has that. Okay. And now 1 plus or minus. If the amount is increasing, so if it's increasing by a percent, we're going to plus. If it is decreasing or decaying, we're going to subtract it. In this case, we're investing money, so we definitely want to be adding. We don't want to invest money to lose it, right? We want to grow our money. So this is going to be a plus, and then the R is the rate. And we see our rate is 2%. We can't just add 2% here, right? We can't add a number and a percent. So first we have to change this 2% to a decimal. And to do that, you can do two things. You can imagine a decimal right after this 2 and move it twice to the left. You get 0.02. Or just divide by 100. 0.02. And that's going to be the number you put here. So 0.02. And then your T is your time. Now you got to be careful with the time, right? So this said it's compounded annually, and how much money does Crystal have in the account when she turns 18, right? So you might jump and say, oh, 18, that's 18 years. But when was the money put in the account? It was put in when she was 2 years old. So that's actually a difference of 16 years. So our answer choice here is 1. 5, which table of values represents a linear relationship? You see the word linear? You immediately think constant rate of change when we are adding, right? Add that word adding in there. Okay, and you do want to find the rate of change by finding the difference on both sides, but usually they give you a break with the x's. So if you notice, in every single x table, it's going to be plus 1, plus 1, plus 1, plus 1. Same thing in 2, same thing in 3, same thing in 4. So I'm going to go ahead and skip finding the difference between the x values since all of the differences are 1. We just want to look for a constant rate in the y values or where it's f of x. So from 3 to negative 2, it's plus 1. Negative 2 to 1 is plus 3. Then we get plus 5. We get plus 7. So that's not constant. And if you wanted to take a step further, just to show you a relationship that might be useful in the future, you notice that all of these are plus 2. Since the second difference is constant, this is actually quadratic. Okay, but back to the question at hand. Let's go to number 2. So from 1/2 to 1, it's plus 1/2. From 1 to 2, it's plus 1. It's plus 2, it's plus 4. And if you notice, it's actually doubling every time. So I'm going to go ahead and erase all of that and just say, oh, it's times 2, right? So this is exponential because it may look constant, but that's multiplying. And we know linear is when we're adding, constant rate of change. Okay, number 3, from negative 3 to 1 is plus 2. From negative 1 to 1 is plus 2. We get plus 2. We get plus 2, right? So all of those are plus 2. Our answer should be 3. At this point, I like to check the last one just to be safe. This is plus 1. That's plus 1. But now that's plus 7, right? And I think that's plus 19, if I did that correctly. At the very least, that is not constant. So yes, our answer choice is 3. Question 6, which domain would be the most appropriate set to use for a function that predicts the number of household online devices in terms of the number of people in that household? And we have examples of integers, whole numbers, irrational numbers, rational numbers. And we definitely need to know what each one of those things mean, right? So whole numbers is going to be like 1, 2, 3, 4, on and on and on and on. So not including, usually it's not including 0. Sometimes it can. We can add that in there. But it's definitely not including the negative numbers, the negative whole numbers. While integers now is going to be ... on and on forever. Negative 2, negative 1, 0, 1, 2, and on forever, right? So whole numbers do not have negatives. Integers do have negatives. Okay, so now we go to the rational numbers. So the rational numbers include all the integers and also all of the fractions, any fraction in between. So for example, so ... let's say negative 2, negative 1.7, negative 1, negative 1/2, 0, 3/4, 1, and again, on and on forever. And then irrational, which I'm running out of space with, down here, it's going to include all types of decimals. All types of decimals. So if you notice, I have a decimal in the rational numbers. We call this a terminating decimal because it ends. Let me add in a fraction here. So yes, 3.4 and 1 counts, absolutely. But what if we had 1/3, right? The decimal for 1/3 would be 0.33. It would go on forever. We call this a repeating decimal. So every decimal in the rational numbers is either terminating or it's repeating. Irrational is now adding in decimals that never end and never repeat. So I'm talking about numbers like, so negative pi, -2, -1, 0, 1, 2. E is an irrational number. It's about, I think, 2.718. 3, pi is 3.14159, on and on and on, never stops, never terminates, never repeats, right? So that's the irrational numbers. So which domain would be most appropriate to predict the number of online devices, right? Okay, so usually what you want to think about here is can you have fractions? So fractions are decimals, right? And can they be negative? That's usually 2 good questions to start with. So can you have a fractional online device? No, right? You're not going to have half a laptop or half a smartphone. So anything that includes fractions can be eliminated. So the rational numbers and the irrational numbers are gone. Now we just have to decide if it's whole numbers or the integers. Can you have a negative number of devices in a household? Also no, right? You can't have -4 Xboxes or other online devices. So the integers are gone, has to be the whole numbers. Number 7, the inequality 7 minus 2 over 3x is less than x minus 8 is equivalent to. Okay, so this we're going to have to solve. So let me, just wanted to zoom out a little bit so I could have more space. There we go. Okay, so we got 7 minus 2 over 3x minus x minus 8. And we want to solve for x. So we need to get these 2 terms on the same side of this inequality symbol. So I'm going to add 2 over 3x to both sides. Right, and x doesn't have a fraction in front of it. It has an imaginary 1. So we know we can rewrite that as 3 over 3x, because 3 divided by 3 is 1. So 2 plus 3 is 5. So we get 7, that cancels out, is less than 5 over 3x minus 8. Now we add 8 to both sides. Those 8's cancel out. 7 plus 8 is 15. So we get 15 is less than 5 over 3x. I'm going to rewrite that over here. So we got 15 is less than 5 over 3x. And it's times like this where I like to rewrite that term a little bit. So this x, whenever the variable is next to a fraction like this, it pairs with the numerator. Always, if you're going to rewrite it, put it in the numerator. So this is 5x over 3. Okay, so we have this 15 here. What if we wanted to rewrite that with 3 in the denominator? Put that over 1. Multiply the top and bottom by 3. 3 times 15. So we get 45 divided by 3 is less than 5x over 3. Now we have 45 is less than 5x. Divide both sides by 5. We get 9 is less than x. And x is, so when you switch the direction now, you need to flip the inequality symbol. X is greater than 9. And that answer choice is 1. Question number 8, the value in dollars v of x of a certain car after x years is represented by the equation v of x equals 25,000 times 0.86 to the x. To the nearest dollar, how much more is the car worth after 2 years than after 3 years? So this is another question like this one we did up here. It's the same formula. Okay, but this is an example of depreciation. So just for context, this would have been 1 minus a certain number, and 1 minus 0.14 will get you 0.86. So this is depreciating at a whole percentage of 14%. Just to put that in perspective. We don't necessarily need that though. So what we can do is put this in the graphing calculator, put it in y equals, and do 25,000 times 0.86 raised to the x power. And now we're going to go to our table. So after 2 years, how much is this car worth? So at 2 years, it's worth 18,490. And after 3 years, it's worth 15,901. By the way, I am getting this from the table right here, from Y1. So I can quit 18,490 minus 15,901. We subtract it, we get 2,589, which is answer choice 1. Question number 9, which function has the same y-intercept as the graph below? Well, this y-intercept is -3. Okay, now it looks like all of our answer choices here, not all of them are solved for y. One of them is, so what we can do is just put that in real quick. If we simplify it, 12 divided by 4 is, well, we can't. Well, we can. 12 divided by 4 is 3 minus 6 divided by 4 is 3 over 2x. So we get 3 minus 1.5. 3 over 2 is 1.5 as a decimal. X. Second graph. And when y is 0, x is 2. So this has a y-intercept of 2, so it's not 1. For the rest of them, we're going to have to solve for y first. And I personally like to start with the easier ones, because why not? So let's look at 4. Subtract 3 on each side. We get y equals 6x minus 3, and what do you know? That minus 3 tells us that the y-intercept is -3, and our answer choice is 4. Feel free to always put that in your graphing calculator if you just want to, be extra sure and careful. You look at the graph, it does cross at -3. It's kind of hard to see though. So go to the table. When x is 0, y is -3. Perfect. And question number 10. Fred is given a rectangular piece of paper. If the length of Fred's piece of paper is represented by 2x minus 6, let's draw this. So the length is 2x minus 6, and the width is 3x minus 5. I'm going to write it up and down like this. Then the paper has a total area represented by, I'm going to go ahead and use the area method here since I already have it kind of set up like that. So in this box, we get 2x times 3x, which is 6x squared. In this box, we get 2x times negative 5. 2 times negative 5 is negative 10. Keep the x. In this box, we get negative 6 times 3x, which is negative 18. Keep the x. And negative 6 times negative 5 is positive 30. And we can combine these two terms here. Negative 10 plus negative 18, we get negative 28x. Keep these terms. We get 6x squared. We get positive 30. That's answer choice 2. This is another calculator one, by the way. So again, y equals, let's go ahead and put in 2x minus 6 and 3x minus 5. We're multiplying those, right? Because the area is length times width. So we got to multiply those two, which is why I did that before. All right, and now in y2, you're going to put each answer choice. Again, I'm going to just jump to the correct answer. Go to second graph. Our tables are identical, so 2 is the answer. 11. The graph of a linear equation contains the points 3, 11 and negative 2, 1. Which point also lies on the graph? Okay, so we know that a line is represented by y equals mx plus b, where m is the slope and b is the y-intercept. So first things first, let's find the slope between these 2 points. So I'm going to do 11 minus 1 divided by, I have to go in the same order here, 3 minus negative 2. 11 minus 1 is 10. 3 minus negative 2 is the same as 3 plus 2, which is 5. Divide, and we get 2. So we have y equals 2x. We don't know what b is yet. Right, so to figure out b, let's substitute in x and y. So any point, I'm going to choose this first one. X is 3, y is 11. We get 11 equals 6 plus b. When you subtract 6 on both sides, you get 5 equals b. So this is y equals 2x plus 5. Now let's go to y equals, and put that formula in. 2x plus 5. Second graph, and we're going to look for each point here. So when x is 2, y is 9, and that is answer choice 4. There is also a way you could skip all of this work as well. So you go to Stat, Edit, make sure both of these lists are cleared, and we're going to put both points here. So we have the point 3, comma, 11, so 3 goes into L1, and 11 goes into L2. And negative 2 goes into L1, and 1 goes into L2. You're going to press Stat, Calc, and you're going to go to Linear Regression, and you can see it tells us the slope is 2 and the y-intercept is 5. That could have also given you this equation. And again, you'd put it in y equals, go to the table, and find that y is 9 when x is 2. Okay, 12. How does the graph of f of x equal 3 times x minus 2 squared plus 1 compare to the graph of x squared? So this here is what we call a parent function. And the parent function is of the form a times x minus h squared plus 1. Sorry, not plus 1, plus k. And a is going to stretch so if this is our parent function, it's just this regular old parabola. So it's going to stretch it by making it narrow or wider. And if it's negative, it's going to flip upside down. So I'm just going to write flip. All right, h is going to shift us left and right. And if we're subtracting, it's going to shift to the right. And if we're adding, it's going to shift to the left. And k is going to shift us up and down. And if we're subtracting, it's going to shift down. And if it's adding, it's going to shift up. So these are all shifts that you should memorize because they don't always give you nice functions like they are here. So because they're actually giving it to you as a nice function, I'm going to also show you how to do this using the graphing calculator, but this down here is definitely something you should know. And using that, we can see, so when a is greater than 1, it's going to get narrow. And when a is between 0 and 1, it's going to widen. So since 3 is greater than 1, it's going to get narrow. So we're looking for the words narrow. So it's not 4 and 1. We're subtracting inside, right? And inside these parentheses, it's going to be backwards. So this is going to go to the right 2 times. So we see left here, so it can't be this one. This says right. And it would be nice to check the last one just to make sure. They both said 1 unit up. Actually, they all said 1 unit up. So we know that's correct. I'm circling the wrong one. So we want right 2 units, up 1 unit. So our answer choice here is 2. And let me show you how you would do this on the graphing calculator. So you're going to put x squared, our parent function, into y1. And press graph here just to see what it looks like. So that's our parent function. Go back to y equals and put the new one. 3 times x minus 2 parentheses squared plus 1. Go back to graph. So how does this new parabola compare to the parent function? You can see it shifted right twice and up once, and it got a little narrow. And for this will be the last question for this video. I will do questions 13 through 24 in a different video. And this was the January 2015 Regents.